Every day, large quantities of liquid products are transported into and out of industrial facilities. These products are generally carried by tank trucks, tank cars, or barges. During the transfer of bulk liquids, operators have many responsibilities. An operator's specific duties depend on the liquid involved, the type of container used, and the method of transfer. During any bulk liquid transfer, the primary goal is to handle the liquid safely and efficiently. To do this, an operator should know the proper handling procedures, including emergency procedures in case there's a spill or an accident. He should also be aware of some specific characteristics of the liquid. 5 basic characteristics of a liquid that an operator should be familiar with are the liquid's toxicity, its viscosity, its volatility, how it responds to changes in temperature, and how it responds to changes in pressure. The toxicity of a liquid is how poisonous or toxic it is. Exposure to toxic liquids can result in burns, respiratory problems, and even death. Operators must be extremely careful when working with toxic liquids to avoid accidents and prevent leaks. Viscosity is a liquid's resistance to flow. More viscous liquids are thicker and have more resistance to flow than thinner, less viscous liquids. As a result, more viscous liquids often require pumping or pressurizing to make them flow. The volatility of a liquid refers to how easily it can become a vapor. Liquids that are highly volatile vaporize easily. The vapors produced by highly volatile liquids often ignite easily. So a liquid that's highly volatile must be handled with care to prevent fires or explosions. But even if the vapors don't ignite easily, they should still be handled carefully, since many of them can pose a respiratory hazard. Another important characteristic of a liquid is how the liquid responds to changes in temperature. For example, as temperature increases, the liquid in a tank expands. This condition is sometimes called thermal expansion. To allow for thermal expansion, a tank shouldn't be filled all the way to the top when it's loaded. Decreases in temperature are also a concern. If the temperature gets too low, some liquids may lose their ability to flow. These liquids are usually carried in insulated tanks that may include heating coils or heating panels. Changes in pressure can also affect the handling of a liquid. For example, during loading and unloading, a vacuum may develop inside a tank. If this happens, the tank may be crushed by the air pressure outside of it. The development of a vacuum inside a tank is known as pulling a vacuum. To prevent a vacuum from developing, vacuum vents allow air into the tank to equalize pressures during loading and unloading. The buildup of static electricity increases the chances of sparking. If sparking occurs near a tank's manway, where a mix of air and vapor may exist, a fire and explosion hazard is created. A common way to deal with static electricity is to use a grounding cable. A grounding cable draws off electricity to ground. The cable should be securely attached before the manway cover is opened, and it should remain in place until the cover is closed. When a grounding cable is properly attached, one end is connected to the metal frame of the tank, and the other end is connected to a grounded metal structure or piping that's separate from the tank. Every liquid has its own characteristics that affect how it must be handled, and some characteristics may make a liquid hazardous. To handle a hazardous liquid safely, an operator must follow specific safety precautions associated with the liquid. A lot of information about hazardous materials can be obtained from sources such as material safety data sheets, standard operating and emergency procedures, and placards on the liquid tanks. Tank trucks typically have at least 4 placards, one at each end and one on each side of the tank. Some placards include an illustration that indicates the dangers of the liquid in the tank. For example, this placard represents a flammable liquid. This one represents a poisonous liquid. Placards often include a 4-digit number that can be checked against a list to identify the specific liquid in the tank. Operators can also use other sources to find out about hazardous materials. For example, the Chemical Transportation Emergency Center, or ChemTrek, can be called for advice on how to respond to an emergency involving hazardous materials. Whenever hazardous liquids are being transferred, certain safety equipment should be accessible. For example, operators should have access to first aid gear, eye wash fountains, and immersion showers. Facilities usually have an emergency eye wash and shower station at each loading site. These stations are often hooked up with an alarm system to a control room so that immediate help can be obtained in an emergency. Many loading sites also have firefighting equipment, drain pads for collecting runoff from any spills that may occur, and lights, since product transfers sometimes occur at night. During a transfer, loading area personnel should remain close by to watch for any abnormal conditions. Adequate protective gear must be worn. This may include rubber boots, rubber gloves, face shields, and protective suits. Depending on the situation, respirators or self-contained breathing equipment may also be required. In this topic, we described some basic characteristics of liquids, and we looked at procedures involved with identifying and handling hazardous materials. Now take a moment to try some practice questions related to this material. Tank trucks are a common sight at many industrial facilities. While not all tank trucks are identical, many of them share some common features. For example, each tank truck must carry a spec plate. A spec plate lists the design specifications that the tank meets and the Department of Transportation, or DOT, classification for the truck. Most tank trucks also have a ladder which provides access to the top of the tank. At the top of the tank is a manway and a number of valves and vents. The valves on a typical tank truck include bleeder valves, which are used to bleed off pressure before the manway cover is opened, and other valves for opening and closing product lines in the tank. The sizes and number of vents on a tank truck depend on the size and type of tank. The vents can include both pressure vents and vacuum vents. Pressure vents release any excess pressure that builds up in the tank. Vacuum vents admit air to the tank to prevent a vacuum from developing in the tank. Tank trucks also have a spill dam around the manway cover to hold any spilled product. If a spill occurs, it should be cleaned up promptly. On this truck, spills can be removed for safe disposal through a drain hose. Components called rollovers are built into the front and back ends of the spill dam. They help prevent the tank from being punctured and the valves and vents in the manway cover from being damaged if the truck rolls over. Another feature that many tank trucks have is an internal safety valve located in the product outlet. Its purpose is to prevent product from flowing through the product outlet during an accident or emergency. In the arrangement illustrated here, a hydraulic pump has to be used to manually open the internal safety valve during normal unloading operations. But the valve is also designed to close automatically if there's an accident or emergency. This is possible because the tubing that carries hydraulic fluid from the pump to the valve has a plug that's both fusible and frangible. The plug is fusible because its center will melt if it's exposed to fire or extreme heat. It's frangible because it can be broken during an accident or emergency. If the plug melts or is broken, hydraulic fluid will escape from the system. As a result, pressure that's holding the safety valve open is lost, and the valve closes. Also connected to the internal safety valve is a remote emergency shutdown device. It has a valve that can be opened manually to relieve pressure against the internal safety valve and allow the safety valve to close. It also has a fusible and frangible plug. The emergency shutdown device is located some distance away from the pump used for normal operations. This way, it may be possible to close the internal safety valve during an emergency, even if the pump that's used in normal operations can't be reached. Those are some of the features normally found on tank trucks. There are also various types of equipment that can be used along with a tank truck during a transfer. These components may include pumps or compressors, hoses and couplings, safety and firefighting equipment, vapor recovery equipment, and grounding cables. Of course, the exact equipment that's used depends on the type of liquid being transferred. Transfers involving tank trucks are normally made at loading racks. A tank truck loading rack is basically one or more freestanding structures called islands. An island typically has loading arms on both sides so that a tank truck can load from either side. Each loading arm typically has its own meters, gauges, and piping. The specific steps involved in loading a tank truck can vary depending on the liquid, the type of tank truck, and the method of loading. However, there are some general considerations that apply to all loading procedures. For example, to move any bulk liquid from one location to another, flow must be produced. One way to create flow is to allow gravity to drain a liquid from a tank at a higher elevation to a tank at a lower elevation. Another method involves pressurizing a tank with a compressed gas to force the liquid out of the tank. Liquid can also be moved from one place to another by pumping. In our example, we'll use the pumping method to load a tank truck through the top. The procedures for loading a tank truck consist of some general tasks, including weighing the tank truck, spotting the truck at a loading rack, making the necessary connections, transferring the liquid, disconnecting the loading equipment from the truck, and releasing the truck. The first step in loading a tank truck is to weigh the truck. This provides a reference so that when the truck is weighed after it's loaded, the amount of liquid in the tank can be determined. Once the truck has been weighed, it's driven to the loading rack, where it's spotted. Spotting refers to positioning the truck at the loading rack. Once the truck is spotted, the ignition is turned off and the parking brake is set. Then the driver and the operator check the paperwork for the truck to ensure that the truck is approved to carry the liquid to be loaded. Wheel chocks are then placed under the truck to keep it from moving while it's being loaded. Next, the operator performs a general inspection of the truck and equipment before making any connections. For example, he checks the tank for any obvious signs of damage. He checks the safety attachments on the truck, including the handrails and ladders. He also makes sure that all valves and vents are in good condition, that all placards are accurate and in place, and that the product outlet valve on the truck is tightly shut. During the inspection, the operator also checks that the loading arm on the loading rack moves freely, that the proper hoses are being used, and that there are no leaks in the system. If pumps, compressors, or vapor recovery equipment are used, he also makes sure that they're in good working order. After he completes the inspection, the operator attaches a grounding cable in order to ground the tank truck. Then he uses the access equipment to reach the tank and prepare for the transfer. Before he opens the manway cover, the operator relieves any excess pressure in the tank by slowly opening the bleeder valve. Once pressure has been relieved, the cover can be unbolted. The operator then opens the cover and looks inside the tank to make sure that it's clean and ready to receive product. Next, he lowers the loading line into the tank. The line should be lowered as far as possible into the tank to minimize splashing during loading. The operator then opens the valve on the loading arm and returns to the loading rack. There, he presets a meter for the amount of product to be loaded. This meter is designed to shut off the flow automatically when the desired amount is reached. The operator then double-checks the valve lineup to make sure that the product to be loaded is coming from the correct storage tank. If the lineup is correct, he opens the valve in the line from the storage tank, and then opens the valve in the product line leading to the tank truck. Finally, he starts the pump to begin the transfer. During loading, the operator watches for leaks or other abnormal conditions. He also checks the tank level to make sure that enough room is left to allow for thermal expansion. The first thing that the operator does is shut off the pump. He then closes the loading valves in the reverse order from which they were opened. After closing the valve on the loading arm, the operator removes the loading line from the manway. He also takes a sample of the liquid for analysis to verify that the product meets specifications. Then he bolts the manway cover back into place using a crosswise pattern to evenly compress the cover gasket. After closing the bleeder valve, the operator attaches a safety seal to the manway cover to prevent tampering with the product. He also attaches a product tag to the cover, which provides information about the liquid in the tank. A safety seal and a product tag are also attached to the outlet valve on the truck. With the tags in place, the operator removes the grounding cable and the wheel chocks. Once he's sure that all safety precautions have been met and the transfer procedures are complete, the operator signs the necessary paperwork and gives the driver permission to move the truck from the loading rack. When the truck leaves the loading rack, it's taken to the scales where it's weighed again before it leaves the facility. The tank truck's empty weight can then be subtracted from its full weight to determine the exact amount of product loaded. The top loading procedure that we just saw isn't the only way to load a tank truck. For example, some products are bottom loaded. Most of the procedures for bottom loading are basically the same as those for top loading. The main difference is that with bottom loading, the product line is connected at the bottom of the tank truck. The procedures for unloading liquid from tank trucks vary depending on the type of tank truck and the type of liquid. One method involves pressurizing the tank with a compressed gas, such as air or nitrogen, to force the liquid out. For example, in the arrangement represented here, compressed air is admitted to a tank through a hose that's connected to a vapor valve on top of the tank. As the compressed air enters the tank, it forces the liquid out of the tank through a product line. A hose that's connected to the product line carries the liquid from the tank to storage. Now let's see how an operator uses this method to unload a tank truck. The general steps he'll follow are the same as those used for any type of product transfer. First, the truck is weighed. Then it's sent to the loading rack where it's spotted and its papers are checked. Next, a general inspection of the truck and equipment is made. The checks made are similar to those done prior to loading a tank truck. After the operator completes the inspection, he samples the contents of the tank. Then he prepares to make the required connections. He starts by attaching an unloading hose that connects the truck's product outlet with the line leading to the appropriate storage tank. Then he connects the air hose to a vapor line at the top of the truck. He sets a regulator to the desired amount of air pressure, and then he opens a valve to allow air to flow through the hose to the truck. At that point, the operator returns to the top of the truck and opens two valves. One valve allows compressed air into the tank. The other valve allows liquid to flow out of the tank through the product line. During the transfer, the operator checks for product flow by feeling the unloading hose for vibrations caused by the moving product. He also watches for leaks or any other abnormal conditions. When the transfer is complete, the operator closes the air valve on the truck and shuts off the air supply. Then he closes the product valve on the truck and disconnects the air hose. To bleed excess pressure off the tank, the operator temporarily reopens the air valve. He also opens the manway and makes sure there isn't a significant amount of liquid left in the tank. The operator then continues to follow standard procedures for safely and properly disconnecting and releasing the truck. Finally, the empty tank truck is weighed before it leaves the facility to determine the amount of product unloaded. That's one procedure for unloading a tank truck. Of course, there are other methods, but regardless of the method being used, there are some safety concerns that should be followed. For example, after unloading, some liquid called a heel will generally remain in a tank truck. For that reason, the placards identifying the material must remain on the tank truck until after the tank has been cleaned. Also, regulations established by the Department of Transportation and other agencies should always be followed when transferring bulk liquids. In this topic, we looked at some features of a typical tank truck, and we saw some basic procedures for loading and unloading a tank truck. Now try some practice questions related to this material.